Hello everyone, my name is Marcel Ruoff and I will be presenting our work on ONYX, an intelligent agent that is able to learn how to handle new natural language inputs through interactive task learning. This work was done with Brad Myers from Carnegie Mellon and Alexander Maedche from the Karlsruhe Institute of Technology. First, we give a short summary of ONYX. ONYX is able to learn from users how to handle new natural language inputs through demonstrations in the GUI as well as through already known natural language inputs. ONYX particularly contributes with its ability to provide suggestions during the demonstration process, with follow-up questions to address ambiguities in the demonstrations, and through visual and textual aids that display ONYX's understanding. Furthermore, ONYX is able to generalize its learned natural language inputs. Our work is motivated by the increasing ability of users to interact through natural language with their smartphones, the web, or specific applications like data visualization tools. However, even though the breakdowns decrease due to recent advances in natural language processing, natural language interfaces can still break down due to missing understanding of unknown natural language inputs, partial or incorrect understanding, or when users ask for unsupported functionalities. For example, the depicted natural language input, combine all states with less than 10 million inhabitants, should aggregate the data points for all states in the US with a population of less than 10 million. However, most contemporary natural language interfaces for data visualization tools get natural language inputs like this only partially correct. Existing studies like SIGCHI or AutoVCI have shown that interactive task learning is a promising approach to learn missing or adapt partial and incorrect understanding. However, the support to users during the demonstration process and the clarification of ambiguities still has potential for improvement. In the following, we show how ONYX implements the features introduced before. ONYX consists of a data visualization tool and a natural language interface. First, we only show the dates for texts with more than 500,000 cases into the natural language interface. After we enter this natural language input, ONYX realizes that it does not know how to perform this natural language input. It explains that we can demonstrate the meaning of the natural language input by adapting the visualization with our mouse or no natural language input. ONYX then asks us whether we want to demonstrate a natural language input or try a different one. After we decide to demonstrate, ONYX provides suggestions based on the subpart more than 500,000 cases. It explains the suggestion in the top message through a textual aid to help us understand the suggestion. Furthermore, it adds the suggestion to its current understanding below. As a clarifying follow-up question, ONYX additionally asks us whether we also want to add cases to the visualization. ONYX connects this follow-up question with a blue line to the associated GUI element of the data visualization tool. After answering the question, ONYX adds this step to its understanding of the natural language input and asks us to clarify the rest of the natural language input. In its message, it particularly highlights the part it did not understand. Now we add the dates to the visualization and ONYX learns from this demonstration. We only want to filter for texts now. However, ONYX detects an ambiguity in our demonstration and asks us to clarify it. ONYX connects the follow-up question with the GUI element in which the ambiguity originated. Based on our answer to the follow-up question, ONYX adapts its current understanding. We can now add texts. Since all the parameters of our natural language input were utilized in the demonstrations, ONYX prompts buttons to finish the demonstration. After finishing the demonstration, ONYX generalizes the demonstration and we are now able to utilize similar natural language inputs, such as now only show the dates for Ohio with less than 10,000 deaths. In the second example, we demonstrate that the functionality of ONYX can also be used to learn the concept such as New England. ONYX again did not know this concept before, therefore we have to demonstrate it. To teach ONYX, we have to select all the states that are part of New England. After all are selected, we can finish the demonstration so ONYX can learn from us. When we again use the concept of New England in a different natural language input, ONYX detects that it already knows this concept now. If ONYX would have to be taught the meaning of the natural language input, it would also utilize the concept of New England or other known natural language commands as suggestions. In our evaluation with 42 participants, we were able to show that the features of ONYX help users be significantly more accurate in teaching ONYX new natural language inputs, while not requiring more time. For future work, we plan to address the issue of natural language inputs with multiple meanings. In our formative study, we realized that the same users sometimes utilize the same natural language input to achieve different goals. However, ONYX and similar systems are not able to distinguish between different meanings. Therefore, we plan to utilize the situational context to select the correct meaning, such as the state of the GUI. In doing so, we aim to answer the question of how users can be enabled to clarify the important aspects of the situational context that should be considered for the disambiguation by extending the current functionality of ONYX. And that brings us to the end of my talk today. Thank you very much.